Hey everyone, let's dive straight into this high-yield review of secondary flight controls to help you absolutely crush your private pilot ground exam. If you're prepping for your test, you probably already know the primary controls inside and out: ailerons, elevator, and rudder. But to truly master the aircraft and to pass that written test, we really need to understand the secondary flight control systems. I'm super excited to guide you through this explainer because, honestly, understanding this stuff doesn't just get you a passing grade, it fundamentally makes you a safer, smoother pilot. We're going to treat this study session like a standard flight profile. We'll hit enhancing lift for takeoff and landing, destroying lift for descents, relieving workload in cruise, and finally, automation. First up on our flight plan, enhancing lift. We'll focus heavily on the wing flaps and leading-edge devices that let our aircraft keep flying safely at much slower speeds. Okay, so flaps are the most common high-lift devices attached to the trailing edge of the wing. They offer this beautiful compromise between a fast cruising speed and a nice, slow landing speed. A huge takeaway for your exam is knowing the difference between the four main types of flaps and exactly what they do to your aerodynamics. Let's break them down. Plain and split flaps are the simplest designs out there. The plain flap just hinges down, which increases the wing's camber. That gives you a solid bump in lift, but also moves the center of pressure aft, pitching the nose down. The split flap is a little different. It only deflects from the lower surface of the wing. While it generates slightly more lift than a plain flap, it mostly just creates a massive amount of drag because of the turbulent wake it leaves right behind the wing. Ultimately, when fully extended, both of these produce high drag with very little extra lift. Now check out the slotted flap. This is the most popular type used today, literally on everything from small trainers to massive airliners. When a slotted flap is lowered, a duct, or a slot, opens up between the flap well and the leading edge of the flap. This cleverly routes high-pressure, high-energy air from the bottom of the wing right over the top of the flap. This high-energy air physically delays airflow separation, so you get a much greater maximum lift coefficient than you'd ever get with plain or split flaps. For the test, definitely pay close attention to the Fowler flap. It's technically a specialized slotted flap, but with a major structural twist. Instead of just hinging downward, Fowler flaps slide backward on tracks. Remember this key phrase: Fowler flaps uniquely increase both the camber of the wing and the total wing area. At first, as they extend back, they increase lift dramatically without much of a drag penalty. It's only at the very end of their downward travel that they really start piling on the drag. Before we move to the front of the wing, let's quickly lock in two foundational terms. Camber is simply the curvature of the wing, and angle of attack, or AOA, is the angle between the wing's chord line and the relative wind. Keep these in mind, because leading edge devices are designed to manipulate these exact factors to keep you from stalling. All right, moving to the leading edge. Fixed slots direct airflow to the upper wing surface to delay separation at high angles of attack. Movable slats do the exact same thing, but slide on tracks. They deploy either automatically due to aerodynamic pressure or manually. Leading edge flaps physically extend to increase camber, and leading edge cuffs extend the leading edge down and forward, essentially wrapping the airflow so it sticks better at those high angles. The big picture for your exam: all these devices let the aircraft reach a significantly higher angle of attack before a stall happens. Moving right along to the descent phase. Destroying lift. Sometimes you just have way too much lift and way too much altitude and you need to get down. Enter the spoilers. Spoilers deploy straight up from the top of the wings to purposefully ruin or spoil the smooth airflow. This instantly kills lift and spikes your drag. If you pop them on both wings at the same time, you can dump altitude fast without gaining excess airspeed. Pretty handy, right? But on many aircraft, they also work asymmetrically for roll control. Turn the yoke right, the right spoiler pops up, dropping that wing, and the best part is, it completely eliminates adverse yaw. Finally, on touchdown, deploying spoilers destroys any leftover lift, firmly planting the plane's weight on the wheels so your brakes actually work. Okay, we've descended, leveled off, and we're cruising. Flying shouldn't be an arm wrestling match with the yoke. Let's talk about relieving pilot workload with trim systems. But before we get into the heavy engineering here, I have a very serious, highly technical question for you. Why did the airplane get sent to its room? Because it had a bad altitude. Okay, groan all you want, but seriously, a bad attitude or altitude will absolutely ruin your cruise flight. Thankfully, trim systems aerodynamically assist our flight controls, so we don't have to hold constant, exhausting pressure on the yoke. Let's see how they actually work. The most critical thing here is understanding the logic of a basic trim tab. It's a small, hinged surface on the trailing edge of the elevator. To hold the elevator in place, the trim tab actually moves in the opposite direction. Let's trace it out. You want to pitch the nose down, so the trim tab moves up. The wind hits it, forcing the main elevator down. That downward elevator catches the wind, pushing the whole tail up, which levers the nose down. Always remember for the test, the standard trim tab moves opposite to the primary control surface. A vital distinction for your exam is knowing the difference between a normal trim tab and a balance tab. A regular trim tab is adjusted manually by you, the pilot, using a wheel in the cockpit. A balance tab looks identical, but it's mechanically coupled right to the control surface rod. When you move the primary control, the balance tab automatically deflects in the opposite direction. The airflow hits the balance tab and physically helps you push the main surface, which is an absolute game changer for lightning heavy control pressures on bigger planes. Now here is the brilliant exception to our opposite direction rule, anti-servo tabs. You'll find these on planes equipped with a stabilator. That's where the entire horizontal tail moves as one massive piece. Stabilators are almost too effective, making the controls feel dangerously light. To fix that, an anti-servo tab moves in the same direction as the trailing edge of the stabilator. So stabilator goes up, the tab goes further up. It purposefully fights you, making the controls feel heavier so you don't over-control the airplane. And don't forget two other common types of trim. First, ground-adjustable tabs. This is literally just a piece of bendable metal on the trailing edge of the rudder. If the plane pulls to one side in cruise, your mechanic will just bend it a little on the ground until it flies straight. Trial and error. Second, the adjustable stabilizer. Here, a jack screw pivots the entire horizontal stabilizer. You see this mostly on jet transports, but it absolutely shows up on some light singles too. Finally, let's look at the ultimate workload reliever. You're trimmed out perfectly, but you need to read an approach plate. It's time for automation and autopilot basics. Simple autopilots use gyroscopic attitude indicators and magnetic compasses to drive servos connected to your flight controls. For the ground exam, know the difference in capability. A single-axis autopilot only controls roll around the longitudinal axis, meaning it just drives the ailerons to keep the wings level. A three-axis autopilot controls roll, pitch, and yaw, driving the ailerons, elevator, and rudder. But the most important thing? Every single autopilot has a disconnect safety feature. As pilot in command, you always have the ability to click it off and fly the plane manually. Understanding how flaps create lift, how spoilers destroy it, and how trim and autopilot save your arms will help you ace that written test and, way more importantly, make you a smarter, safer pilot. So as you prep for your check ride, ask yourself, in a sudden emergency situation, which of these secondary flight controls would be your absolute most critical tool? Really think about it. Good luck on your ground exam. I know you're going to crush it. If you found this explainer helpful, please hit that like button and subscribe for more flight training explainers. Fly safe, and I'll see you in the next one.